Welcome to Part 2 of Lab 4 for Introduction to Geosciences. For this lab exercise, you will need a calculator, a pen or pencil, and scratch paper to set up and complete your calculations. You may pause the video to gather these items. Remember, all answers will be entered into the video quiz interface, so there will be no need to upload files or submit your lab in any other format. In this portion of Lab 4, you will be calculating the speed at which the Pacific Plate is moving and the direction it is moving in. I will be demonstrating how to measure the distance between the Hawaiian Islands in Google Earth Pro. I will explain the equations you will use to calculate the speed the islands are moving. Then I will ask you to make the calculations based on the information provided. You will enter your answers directly into the quiz on this video. If you would like to follow along in Google Earth Pro, please feel free to do so. However, it is not necessary. We are going to examine 4 Hawaiian islands: the Big Island, Maui, Kauai, and Nihoa. The purpose of this portion of the lab is to understand how hotspots work, the direction that the plate is moving, and how to calculate how fast the plate is moving now, and the speed at which it has changed over time. The first thing we are going to do is locate Hawaii on Google Earth. Type Hawaii into the search box and click Search. When Google Earth zooms into Hawaii, it will not have Nihoa on the map. We need to readjust it to show Nihoa. Nihoa is a small island in the northwest part of the island chain. We will now place a pin in the center of each island because we are going to measure the distance between them. Type Nihoa, Hawaii into the search box and click Search. Google Earth will zoom in to Nihoa. Click the thumbtack in the toolbar and drop a pin into the center of the island. Label this pin Nihoa, Hawaii. Click OK to save. Next, type Maui, Hawaii into the search box and select it from the list. When Maui is centered on your screen, click the thumbtack in the toolbar and drop a pin into the center of the island. Label this pin Maui, Hawaii. Now, type Kauai into the search box and select it from the drop-down menu. When the island of Kauai is centered on the screen, click the thumbtack and drop a pin into the center of the island. Label this pin Kauai, Hawaii. Now, in the search box, type Island of Hawaii and select it. We will be calling this the Big Island because that is what it's usually called. When the Big Island is centered on the screen, click the thumbtack and drop a pin into the center of the island. Label this pin the Big Island, Hawaii. Now zoom out so you can see all of the pins placed on all of the islands. We are going to measure the distance between the islands in centimeters, just like we did on the last exercise. We will start with Nihoa on the left and move to the Big Island on the right. Click the ruler in the toolbar. First check that you are measuring the line path in centimeters. Then click the tack on Nihoa. Next, click the tack on Kauai. When the measurement box comes up, save this measurement as Nihoa to Kauai. Click OK to save. Now click the ruler tool again and check that you are measuring the line path as centimeters. Click the tag on Kauai and measure to Maui. Save this measurement as Kauai to Maui. Lastly, click the ruler again, then click the tack on Maui and measure to the tack on the Big Island. Label this measurement Maui to Big Island and then save it. We will access these later and use the measurements to determine how fast the Pacific Plate was moving over the Hawaiian hotspot at which point in time. Now we will calculate the speed the Pacific Plate was moving between the formation of the Big Island and Maui. We will need the measurements we just took to calculate the speed. You can find the named measurements under the recent places on the left. Right-click it, then to open it, click Properties. When the box pops up, click the Measurement tab. Write down this measurement of 15,872,416 centimeters. To calculate the speed of the plate, we will use the equation speed equals distance over time. Remember, we are measuring in centimeters per year, so your answer will be in centimeters per year. We will need to calculate the time that we need to use first, though. From the textbook, we see that Maui formed 1.1 million years ago. We also see that the Big Island is still forming, so we will say that it formed 0 years ago. (1,100,000) minus 0 equals 1,100,000 years. This is the number of years we will use in the equation. So the speed that the plate is moving equals the distance we pulled from the measurement in Google Earth, which is 15,872,416 centimeters, divided by 1,100,000 years. Use your calculator to figure out the answer, then enter it into the quiz interface. Round to 2 decimal places and be sure to include your units of measurement in your answer. We will now use the same equation to determine how fast the Pacific Plate was moving between the formation of Maui and the formation of Kauai. First, let's retrieve the measurement from Google Earth. Write down the distance from the dialog box, 35,614,451 centimeters. Remember, we will use the same equation as before. Speed equals distance over time. To input the time into the equation, we will need to determine how many years passed between the formation of Kauai and Maui. We are given in the text that Kauai formed 4.7 million years ago and Maui formed 1.1 million years ago. (4,700,000) minus 1,100,000 equals 3,600,000 years. We will take the measurement from Google Earth now and sub these numbers into the equation. Speed equals 35,614,451 centimeters divided by 3,600,000 years. Complete the calculation using your calculator then input the answer into the video quiz interface. Round to 2 decimal places and be sure to input the units of measurement. We will be finding the time between the formation of Nihoa and Kauai now, so in Google Earth, we will need to retrieve the measurement between these two islands. Select the saved line from recent places and click Properties. The length will be under the Measurement tab. Write down the measurement of 27,189,339 centimeters. We will use the same equation we've used previously, but once again, we need to find out how many years there were between the formation of Nihoa and the formation of Kauai. So, the text tells us that Nihoa formed 7.2 million years ago. We know that Kauai formed 4.7 million years ago. $7,200,000 minus 4,700,000 equals 2,500,000. So we will sub this into our equation. Speed equals 27,189,339 centimeters divided by 2,500,000 years. Complete the calculation using your calculator, then input the answer into the video quiz interface. Round to 2 decimal places and be sure to input the units of measurement. As you can see, the Hawaiian Islands get smaller as they move more northerly. Zoom out on Google Earth and examine the dozens of sunken volcanoes out past Nihoa, named the Emperor Seamounts. As one of these volcanic islands on the Pacific Plate moves off of the hotspot, it becomes inactive or extinct. As you zoom out on Google Earth, you can see that the extinct line of volcanoes reaches all the way to the Aleutian Islands. Recall from the Scientific American video that as the mantle moves over the hotspot, it heats up and rises, forming a bulge. As it moves further away from the hotspot, the opposite happens. It shrinks and flattens. What is happening to the islands as the crust shrinks over time? This concludes Part 2 of Lab 4.